This is the first video on section 4.8, curvature, and as the name implies, curvature measures how much a curve curves. So the definition, the curvature, which we give the notation is the Greek letter kappa. So we have curvature is the derivative of the unit tangent vector with respect to arc length. And if you think about the process of this is kind of a tedious calculation. So we have theorem 108, which helps us out here. It says a curvature is the magnitude of the derivative of the unit tangent vector divided by the magnitude of the derivative of the vector valued function that you're using to parameterize your curve. So r of t is it's the vector valued function. We're parameterizing our curve. R prime is its derivative. T prime is, t is the derivative of r divided by the magnitude of the derivative of r. So it is the direction of the derivative, but it is a unit vector. And then we calculate its derivative. Why does this work? And really it's just from what we know about derivatives and some algebra. So from the chain rule, we take the derivative of the unit tangent vector. A way to look at that is we take the derivative of the unit tangent vector with respect to arc length times the derivative of arc length with respect to t. That's just the chain rule. What did we learn the derivative of arc length with respect to t was, though, in the previous section? We learned that the derivative of arc length with respect to t is simply r prime of t. And so when we look at our curvature formula, we have the curvature, we have magnitude of the derivative of capital T with respect to s. From what we did over here, we do a little bit of algebra, right? So we have this, and we're just going to divide both of these by the derivative of s with respect to t. So we have derivative of t with respect to s right here. We've solved for that algebraically. We're keeping our magnitudes intact. And then we learned in the last section that ds dt is r prime of t. Okay, so example 109, we have two problems. We're going to find the curvature of these. In this video, I'm only going to do part A because I only have room for part A on my board. In the second video, we'll do part B. So we start with our function. Cosine of t, sine t, 0. This is our vector valued function. Calculate r prime. Calculate the magnitude of r prime, and it's just 1. So what that means is the unit tangent vector is r prime. Because to get the unit tangent vector, we would take r prime and divide by its magnitude, but since r prime is already a unit vector, the unit tangent vector for this example is r prime. So now we just apply the formula from our theorem. All right, well, first we'll calculate the derivative of t, and now we'll use the formula from our theorem. So here's t prime. So our curvature is magnitude of t prime divided by magnitude of r. This is t prime. Its magnitude is 1 because cosine squared plus sine squared is 1. So we already knew this magnitude is 1. So the curvature is 1 divided by 1, which is 1. Let's stop and think about something for a second. What is this curve? It's just the unit circle in the xy plane, right? Because z is 0, so we just have cosine t sine t. And so this is really just the parametric equation of the unit circle. And we're measuring how much something curves. That's what curvature is. And the curvature of the unit circle is 1.